Good evening. This is the live session and sample problem discussion session 8 for polymer reaction engineering. Uh, my name is Rohan Jadhav and I'm the concerned TA for this session. So in this session, we'll be discussing some sample problems which will be helpful for you in solving your assignments for this week. So in today's session, we'll be learning more about radical polymerization and how different aspects of radical polymerization are important in controlling the polymerization rates. Starting from the first one, we have which of the following compounds are considered as chain transfer agents for redox reaction? Chain transfer agents, if uh, if they are introduced intentionally in a reaction, can advance the radical formation by activating higher states of ions and other initiating species. So in this case, methylamine, aliphatic alcohols, and mercaptans, the sulfurs, are effective in engaging the other initiating species and taking this taking the native state to higher state ions, and that is why these three are mainly used as these are the compounds which are considered as chain transfer agents during a redox initiation. So these three are considered as the chain transfer agents for any redox initiation. Moving on to the next question. In the blank suspension polymerization, the polymer is insoluble in its monomer and thus precipitates, contributing to the formation of irregular grains or particles. Since we are talking about suspension polymerization, it is it is quite obvious that there will be the dispersed phase and the dispersion medium. We have a dispersed phase, that is dispersed dispersion medium, and we will be having some dispersed phase. So we have two polymerization methods, powder and bead. So among these, powder suspension polymerization, polymer becomes insoluble in its monomer and it precipitates out, which contributes to irregular grain formation or particle formation. So in this case, powder suspension polymerization, what happens is that during powder suspension polymerization, right, the moment the powder polymerization process, the polymer starts becoming insoluble. It will come out of the uh, insoluble in its monomer. It will start precipitating out, and thus it will contribute to the formation of irregular grain size. In bead polymers, since bead polymerization process, because of its solubility, monomer will form smooth spherical particles, not irregular grains or particles. So that's why powder suspension polymerization process is the process where insoluble monomer will form irregular grains. Next question we have chain transfer agents in redox reaction are helpful in the case where molecular weight of the product is to be controlled. Chain transfer chain transfer redox reactions. What happens is that since the chain transfer agents are formed and they are effective in creating other initiating species, so they are very helpful in controlling the molecular weight of the product which is being formed. Since they can elevate the native state ions to higher state ions and engage other initiating species, that will result in formation of higher molecular weight products. So molecular weight can be controlled by the chain transfer agents during a redox initiation process. Second, so statement one is correct. So among these, you can see that there are two options here. So first, we'll engage both of them. Second is Chain transfer agent results in retardation and rate of reaction. So since chain transfer agents initiate higher state ions, because of this, what happens is that chain transfer agents sometimes uh, result in like the other species, other atomic species, the propagating of the propagation reaction of the polymerization process becomes hindered. So because of that, chain transfer agents also result in retardation of the rate of reaction. So they work in both ways by like increasing the molecular weight of the product, giving it a certain control, and also that the chain transfer agent result in retardation of the reaction. So in that case, the first one would be correct. Moving on. During dispersion polymerization process, usually the yields of polymer particles with sizes in between those obtained by emulsion and suspension polymerization, the nominal particle size range is. So this is a straightforward question which gives which is based on the general definition of dispersion polymerization. So which lies between emulsion and suspension. So amongst these 1 to 10 millimeters of particle size is the nominal particle size range, which is formed during the dispersion polymerization, and the yield form is of this particle size range, and it lies between emulsion and suspension polymerization processes. The compounds which absorb the desired amount of photoenergy to reach its excitation stage and finally react with second compound to generate free radicals is called photoinitiator. Uh, the compounds which absorb the desired amount of photoenergy to reach its excitation stage. This process is called photosensitization. So, and when they finally react with second compound to generate free radicals, uh, the 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 compounds which undergo this process are called photosensitizers, which result in the formation and generation of free radicals. So photoinitiator is the incorrect answer. So that's why the statement is false. The kinetic chain length can be defined as the ratio of polymerization rate by initiation rate, polymerization rate by termination rate, initiation rate by termination. So what is kinetic chain length? Kinetic chain length is nothing but the number of monomer units which react with an active center or radical during the initiation process of the polymerization uh, through to the termination step. So going from initiation to the termination, the monomer units which are reacting with active centers and radicals is called the kinetic chain length. So this will be dependent on initiation, the reaction, and the termination step. So in that case, the first two options, which is describing them as polymerization rate, that is nothing but your RP by first is initiation rate, that is nothing but RI. So from the basic definition, we have that monomer units reacted with active center during initiation and termination step. So that will be even the second option is correct. So in that case, we have RP by RI will be equivalent to RP by RT. That is nothing but the termination step. So with that respect, first two options are correct. Moving on to the next question, we have in suspension polymerization, the average rate of energy dissipation is used to characterize the quality of mixing. In presence of a dispersed phase, the turbulent intensity dash due to the dash in the velocity fluctuations of the continuous phase. Select the correct option sequentially. So again, in suspension polymerization, we will be having dispersed phase and dispersion medium. So the average rate of energy dissipation is related to the mixing phenomena, which controls the particle size density in the suspension polymerization process. So it determines the flow and energy fields inside a vessel, which will be controlling the suspension polymerization process. So what happens is in dispersed phase, turbulent intensity decreases due to the decrease in velocity functions, velocity fluctuation of velocity fluctuations of continuous phase. So what happens is that the velocity function, the velocity fluctuations of continuous phase, there is like a fluctuation in velocity of the continuous phase, making it more turbulent, making it more turbulent. The dispersed phase will start losing its turbulent intensity, and because of which there will be a decrease in the fluctuations of the continuous phase also. So that's why both parameters will decrease significantly, which are related to the average rate of energy dissipation. So the correct option would be both parameters decrease. Moving on to the next question we have. Which of the following types of monomers cannot be used in plasma polymerization for the formation of cross-linked polymers? So in plasma polymerization process, alkanes, cyclic or ring compounds, and unsaturated hydrocarbons, uh, these species usually use the plasma polymerization process for the formation of cross-linked polymers. So, mm, since these can be used, none of these would be the correct answer, since in plasma polymerization process and during the formation of cross-linking of these cross cross-linking of the polymers, alkanes, cyclic ring compounds, and unsaturated hydrocarbons uh, are used. During the chain transfer reaction radical polymerization, the telomerization of polymer occurs if, excuse me, during the chain transfer reaction radical polymerization process, the telomerization of polymer occurs if. Now, what is telomerization? In telomerization, what happens is when the propagation, when the chain length of the polymer will change drastically, uh, which causes the polymerization process to form very small polymers in large number. That process is called telomerization. So what happens during chain transfer process is that if it's the during the chain transfer process, if the rate constant for the transfer reaction, the chain transfer reaction, uh, is very large, like if the reaction is proceeding quickly, then that of the propagation reaction, which means that chain transfer process is overpowering the propagation reaction, while the rate of the reinitiation process is equivalent to the original propagating radical. Then what happens is there won't be any effect on the rate of propagation. So there won't be any effect on the rate of propagation, and because of that, but adversely, what happens is that the chain length will be affected drastically. And in that case, what happens is telomerization will occur, as we just defined, formation of small polymers, formation of small polymeric chains in large numbers. In large numbers. So in that case, what happens is that the transfer reaction rate, that is this transfer reaction rate, will be greater than that of the propagation rate. So amongst these, you can see that option B and C are having the transmission rate greater than the propagation rate. But the other condition would be that the reinitiation rate, reinitiation process, the rate of the reinitiation process is comparable to the original propagation step. So rate of the propagation step. So in that case, this will be the option, since Ka is almost proportional or equal to that of Kp, initial propagating step. So that's why B is the correct. Moving on. In radical polymerization process, sometimes premature termination of propagating polymer occurs due to the transfer of hydrogen or other atoms to the propagating polymer from the same one. So, same monomer solvent or with other initiators. The new radical formed due to chain transfer reaction can again initiate polymerization. So, what will this lead to? So, what happens is that in this case, uh, since we just saw how telomerization occurs, that in radical polymerization, when premature termination of propagating polymer occurs, so this will lead this because the hydrogen transfer or other atomic species, uh, the transfer of hydrogen atom or other atomic species to the propagating polymer from the same monomer uh, because of the same monomer initiator or solvent. What happens is that decrease in molecular weight of the final product can occur as compared to the theoretically determined value, and which and as we saw in the previous question that there won't be any rate change of polymerization, but either decrease in rate of polymerization can occur or decrease in molecular weight of the polymer. So, and there won't be any increase in the rate of polymerization as this is a positive effect. And since premature termination is occurring, there won't be any increase in the rate of polymerization. So these three would be the possible case scenarios which will lead, which will be the fruit of the premature termination of propagating polymers. So uh, based on that, the radical polymerization, radical radical polymerization process, the uh, hydrogen and other atomic species transfer process from the propagating polymer because of monomer and solvent will result in decrease in rate of decrease or no change in rate of polymerization and decrease in the molecular weight of the polymer since premature termination is occurred. Thank you for attending this session, and we'll be uh, we'll be solving the we'll be solving more sample questions in the next session for uh, which will help you solve the assignments for the next week. Thank you.